Welcome everybody. My name is Gary Hansen. I'm with GWR and we'll be training on CB20 today on the operation and functionality of this control cabinet. The whole purpose of this cabinet, I've been informed, and we will correct these manuals for you, was to transfer water from MWD into the City of Upland storm drain and eventually into the West Cucamonga Creek. The hardware involved with this is we have a clay valve, as you can see over here, dumping water into our channel. MWD in their vault has the controls for the flow and for pressure. The main screen on this indicates and shows all those and gives us the status of each. The login for getting into this system is IEUA_admin. Password is the same. And you'll find that on the page 3. You'll see that login is indicated on there. All right.
Is there covered in the manual how to change that?
How to change that? The system administrator would have to do that. So we don't really give a lot of details on that. That's.
And who is the system administrator?
I think that's Damien, right?
Damon's
so he can give you all the passwords and stuff that you want to break, however you want to break those down with privileges, supervisory privileges, and etc. All right. So if you're familiar with any of the other turnouts, this is basically a carbon copy of that. It's been upgraded in technology a little bit. The one over at Orchard Street is the same, but the others has some older technology, older displays, so this does take advantage of some of the graphics on that and brings those to light here, makes it a little easier to use. But other than that, the functionality is pretty much the same on all the others. It's hard to see from here. Afterwards, if you want, we can move around through those screens and etc. So basically, we'll just talk about the screenshots that we have in front of us. The main screen, you'll see on there that it displays the flow set point. It gives you the percentage that the valve is open at the time, the current flow through the valve, and the pressure in PSI and flow, of course, cubic feet per second. From here, we have the ability to log in again, to change our login if we want higher privilege, if we have a function that we wanted to gain access to that we don't have available to us, so we have the ability to do that. There's a valve control screen button, there's a set point screen, site lockout, intrusion alarm reset, and system trend analysis, and we'll go through each one of those in detail. Now the flow set point, if you touch the flow set point, it will go ahead and take you to the set point screen that allows you to change that set point. Or you can go into set points directly either way. So if you forget how to get in there, just touch that button on it and it will get you in there. The next page just shows where our intrusion alarms reset. When you open this up, it should be an intrusion alarm. You want to go ahead and reset that to let the SCADA site know that you are out here and it's not somebody breaking in and etc. Or there's not a failure with the system door or something along those lines. Very good. The alarm screen. Pretty much anywhere, any screen that you're on there, if you have an alarm with this system, the alarm screen button will be there. It'll either turn red or it'll have a red dot on it indicating that you have an alarm condition that needs to be looked at or that you should be aware that it exists. If you hit the alarm screen button, it'll take you there, show you whatever alarms that you're having. Common alarms are going to be with being too high on our pressure, too low on our pressure, too much flow, too little flow, or failure with some of our equipment. We do have our bad signals, which is our open circuit for all our analogs, and we have a few things for power monitoring, such as AC and DC power monitoring. The valve control screen. This is kind of our main screen for coming out here. If you want to make changes, you'll go to the valve control screen. There are two modes of operation for the valve. It's either in auto mode or it's in manual mode. In the auto mode, which is what you see on page 8, you have the ability to change the set point. So you would type the green square, it'll bring you up a dialog box, you type in whatever value you would like for the flow to currently be, and hit enter. That flow will not take effect right away. It gives you a chance to see what you've put in, just in case you walk up to it and put some large number, you put in say 100 instead of 10, it gives you one more chance to be able to go back and change that before you apply it and make it take effect. So it's a little bit of a safety feature. You'll see the apply button to the right of that, so once you've typed in that value, you come back to the screen, you say, okay, yeah, that is what I want. You hit the apply, and that'll make the valve now start to operate at that value. Again, you're able to see the percent open, the flow, and the PSI from there. You're also able to see the total acre feet that has been transferred. You can reset that from this screen simply by hitting the reset flow total, and that'll give you a fresh total. Keeping in mind that at the SCADA, it will still be totalized and etc., but it will reset the current value of this system.
So you're saying it does not reset the total in the SCADA system, but it'll reset the total here locally only? It
will reset the current flow total at the SCADA, but they're going to be totalizing it there, so there'll be a record. It's just you won't have that total will start again.
You won't lose it on the historian, but you'll...
Right,
okay.
Exactly.
But when you reset it, it goes to 0 here, and then
SCADA.
And 0 there. Okay.
Right, for that total.
Right.
But the history doesn't go away.
Right.
Now, the other mode of operation, which you'll find on page 9, is in the manual mode. So when you tap the auto mode button, you'll see that it will change over into a manual mode operation. The flow set point will disappear, and you get a new option. You get a gate manual set point. This is kind of a maintenance situation. So if you want to actuate the valve for some reason, you feel like something's not working right, maybe you made a repair or something and you want to see how it works, you can put in a percentage that you'd like the valve to open to it. Regardless of what flow will come out, it will move to that percent. Okay? So if I want to move it to 50%, boom, I put in 50, it'll go to 50%. I hit execute gate command, then it will go to 50%. If I decide I don't want that anymore, I change it to 0, hit execute, and it'll go back down to 0. So you can operate it in a percent mode operation only. Okay? This does not tie into any flow. The flow will be predicted by the pressure in the line. So whatever the pressure is based on that percent valve open, that's the flow you'll get. So this is really not something we want to do on any kind of a regular basis. It's just strictly a maintenance option if you have the need to do so.
I notice there's no apply button there when you put in on page 9.
There actually is an apply button. It's the execute gate command. So you can type whatever number you want in there.
Oh, okay.
It won't actually move until you hit the execute gate command.
Is that the same thing on the valve control screen where you're in auto mode for?
No, that's only applies in that only applies for the manual.
Okay, so if I want right here, your examples 13 CFS, I would hit that 13 and then hit apply.
Right.
Then do I have to hit execute?
No, the execute command doesn't even come in effect there.
Execute's only for
the manual mode.
Okay.
And then you also see over on the right, you'll have some I/O, status of I/O. This is also gives you a little bit of a troubleshooting indication. If you're having trouble out here, you know the valve's closed, but you're not getting that signal. This is confirmation that you need to go ahead and do some sort of repair work on the valve close signal or the valve open signal, and etc. Now, there are 2 set point screens. When you first enter the set point go-to button, it'll take you to the first screen, and it brings up all the values for your alarm set points. So you'll see on the left-hand side we have our pressure alarms. We have a high, a low, and a low. Now, the spec on this was that the valve will only operate if the pressure is above 60 psi. Doesn't mean you have to set your alarm set point there. You can set it to whatever you want, but I somewhat recommend that be around 60 or above, so that you get an indication that the valve is shutting off when that alarm comes in. Now, over at Orchard Street, we found that they decided to set there's a mechanical shutoff on that valve as well, such that if the valve itself detects a certain pressure, that it will shut off. This should be a secondary safety. If you set that above 60, what will happen is the valve will shut off, but the PLC won't know about it because it doesn't think there's an alarm condition, and the valve won't respond according to the PLC command, so you'll get a valve failure alarm. That kind of threw them off on Orchard Street at first because they couldn't figure, well, we don't have a valve failure alarm. The valve closed because it had low pressure, but that was set above what the software thinks is a low pressure. So if you need that 60 changed, then you should do that and not set the valve above it. Have that software be what enacts first, so that it has a chance to shut the valve off before the valve goes into its mechanical override.
Are these set points available at the SCADA terminals as well, not just
Yes,
here? Okay.
yes. All the set points go back and forth between the two. If you change it here, the SCADA will reflect the change.
Okay.
If somebody changes it at the SCADA, it will be reflected here on the displays. So they both work off the same numerical value, so they won't be different.
And the administrative rights to do that is at IUA admin login, or is it the administrator login?
The IUA admin can make those changes at this time, yes. Okay, and we also have our flow set points for high and low. There's not a high or a low requested on those, just a high and low. And then we also have our set points that we can put in for our flow on this screen as well. So not only can you do it in valve control, you can do it from here as well. Now you'll notice there's a blue section and a green section on this. The blue section is the current values before you came in. So as you come in, you're going to start typing in the values in the green that you want. So you get them all in, everything that you want to have happen. Once you're sure of what you've got, you apply the values in here just like you did on the control screen, only you're going to be applying the others as well. Once that happens, the values in the green box will move over into the blue box, and that's what the system will then operate on. From there, you'll see you have the option of going to set points screen 2. So we look at that on page 11. Our set point screen 2, that is our fine-tuning of the PLC itself, its response time. So you see in there you have analog filter times, you have your over and unders, you have your signal faults, different things like that on how the system operates internally. These values have been used before. Unless you have a real good reason to change anything in here, I'd probably leave those as they are. Okay? And this manual is a good record of what they were before you made a change that caused the system to possibly run erratically. And if you do set these a little bit too low or a little bit too high, then you will get some odd performances on it. Okay. Trending screens. Once you go into the trending screens, you'll be able to see all 3 values on a single screen. You'll be able to see your flow, your position, and your pressure. Now, only one thing about this screen is once you go into it, that's when it starts recording. It does not keep any history. This particular HMI does not maintain history. So what you'll see on there is what came up as you went to that screen. Leave it on the screen for a while and you'll start to see the performance. Okay? Yes, sir.
Does it have a port to record the data to a drive?
No, we don't. No, we don't have that on there. So that wasn't anything that was requested.
Does it have the capability for that?
I'd have to look into that. I think the best place to get that history is, again, going to be from the SCADA.
You know, the reason I bring it up, Andy, is we have a similar system like that down at Prado. We used to just throw in a disk in there, record the data of what was going on at the time, and just bring it back.
Yeah.
I'd have to double check, but I think we'd have to upgrade memory in order to be able to do that. So.
Yeah, it just dumps it into a drive. Like nowadays, they just dump it into a little zip drive.
Right.
Just throw it in.
Yep. Okay, and that kind of covers the operation of the HMI itself. Is there any questions on the HMI performance other than the ones that are already covered? Again, it's pretty straightforward. It's just simple operation. We're basically turning the valve on to a flow set point and watching it run. It is programmed to bring it up slowly. Okay, so for instance, if I type in I want it to go to 50%, it's not going to just shoot to 50%. It's going to bring it up about halfway, let it settle and stable because there'll be some overshoot, and then it'll go halfway again between that point and the target, and it'll inch its way in nice and easy, nice and gently, so we don't have any water hammers or quick shut-offs or anything like that, erratic changes in pressure. And this is really kind of important when it shuts off and it's going to 0, that we kind of inch in, okay, into the closed position. So we've taken that into account. And you saw today they were putting on some speed control valves to also make sure that that operates as required.
I noticed some of these screens show 30.00 CFS or 13.00. Another place is 13.0.
Those are made up numbers just for the manual.
Can you help? If you put in 13.00, is this valve going to open and close based on the pressure here 5,000 times a minute or what?
Well, if the pressure drops below 60, it will close down. It will close down.
So
Once the pressure returns, it will try to go ahead and operate again as normal.
just want to try to find out what's normal.
It's like constantly seeking. Is that what that's
Yeah.
There's a dead band.
Yeah.
It won't. There's a dead band. I don't know what the set is, but if it goes from 13.10 to 13.20, no, it will not adjust the valve.
Oh yeah, no.
Valve flow rate, dead band percentage.
Yeah.
It's right in there.
To 11.
That's your set point in screen number 2. Exactly. That's now I understand the question. Yep. So there's 2% dead band in there. So yeah, we didn't want the valve to constantly make a half PSI or half CFS adjustment back and forth, back and forth. It will have to be 2% of its target value before it makes a move. So for instance, you set it for 100 CFS, it may go to 98.1 and it's just going to stay there. And it's going to consider that good enough. If for some reason it drops just below 98, then it's going to shoot up and try and get closer to 100 again. It'll actually go to 99 with some little overshoot. It'll bring it right in close to 100 because it has a tendency when it shuts off for it to have to go from a motion to a stop. It takes a little while for it to do that, and that allows it to drift into your target pretty good.
And these set points can change.
Yeah.
That set point, you have access to it right there. If you want it to be 4%, you can make it 4.
And when water is going through it, we'll know a better number.
Yeah.
Right. That's why these are on here, because we've got to tune them in, and we haven't had a chance to run that until we get the wiring from MWD to do so. So we'll be doing that hopefully here in about a week or so, I hope. Cross my fingers. All right. Dave, if you want to go over the drawings then.
Okay, I'm going to go over all the drawings, but we'll start on page 51 to 67 because that's this site. And all the drawings are set up basically the same. On page 51, this will be the first, after the title block and all, this will be the first drawing in the package. And it's power distribution. We start with 120 volts. This is the 120 supply in this panel. And on the left-hand side, you'll have everything that's connected directly to utility power, and then everything on the right is everything that's hooked to the UPS power, with the UPS being on the top right. So on the left-hand side, we have the operator interface here, and the heater and the AC are the only things connected to the utility power directly. Then there's a UPS on the right-hand side, and we have the the receptacle is also on the utility power. From there, the UPS will be connected to the receptacle in here, and it's bottom left. And from there, we're going to go to our control power. So we'll have our power supply, and we'll have our cards powered from the UPS. So you have, I think it was 30 minutes. If you lose power, you'll receive signal that you lost power back at SCADA. You'll get all the signals that something's going wrong, and it'll run for 30 minutes. So somebody's going to run up here and fix it. Okay. So once again, page 51 left side is utility power. Right column is UPS power, and at the bottom of UPS power it goes to 24-volt power supply. That's on the next page. The next page is 52 and 67 will be the 24-volt power and where it goes. For the fusing of all this stuff, all the fusing is on the left-hand side there. So for utility power, it'll be the top 3 of them. It'll be all the way to 122. First 4 is utility power. After that is the UPS power. And then we go into the 24, it'll all be fusing. And it's all laid out per, if it's a digital I/O or an analog I/O, the fusing will be close. So all digital, this is would be digital fusing, more digital fusing. This is an individual channel, each individual channel is fused. And then the analog is fused in the analog section of the terminal blocks. Okay. Now on the next page, which is 53, all this is the wiring for the relays in the panel. Gives you your contacts where they're going, and these just happen to be going to the valve for the open and close command, and then there's one spare there, a few trees. Now one thing about these drawings is you don't have a complete set now because we don't have all the information. I just brought them to explain everything to you guys. Everything you have in your hand is correct, it's just incomplete. So you'll see X's where things are not known yet, or some things on the radios are changing. And as it sits today, it is correct. So,
And that's just the MWD wiring, right?
And when the job's done, you'll get the full complete set. Okay, so on the next section, we go from D section for power distribution to section E, which is the control part of the wiring. And the setup on each column is a card. So on the first card, the left-hand side, since these are all inputs, the field's on the left side, the card's on the right. The second column is outputs, so the card's on the left, the outputs are on the right. So you can just look at it and know it's an input or an output because of the direction the wires are headed. And we give it a description of what card it is and where it's located. And there's not too much in here. You have a lot of spares, individually fused, like I was saying earlier, all right here. If you have a signal that goes to a valve, or not, valve's a bad idea. If you have a signal that goes to a power failure, you're going to have a separate signal for the DC power and a separate signal for the AC power, because you could lose your DC power without losing your AC if your power supply went out. So you'll know DC power is what went out. What went out. Use your AC power, you're going to get a signal because your UPS is going to hold up your system for half hour to send a signal to your SCADA that it was the AC power that failed. So you'll get those signals, you'll know exactly what failed back at RP1.
How long will the UPS keep going?
I want to say it was a half hour.
But you said after half hour.
After half hour, if he's just going to shut down on you. I would have to look it up, but from memory it was a half hour is what the spec called out for.
It's too bad.
It's kind of a short time.
Down here and it says that people knock out the transformers all the time.
Yeah.
So then it takes you.
So it will give you short time, and a half hour may be wrong. I'd have to look in the specs. I mean, I don't remember exactly, but I want to say it was a half hour. Okay. So in this next page in the drawings, which would be drawing 55, now you're going to the analog. Once again, since all the field devices are on the left, the card's on the right, that's an input card. The blank space is for future. There's nothing else in there except for the analog inputs. And on this drawing, it's page 55, you'll see that the terminal blocks in the field are all just XX because we'll need that information from MWD to fill it in so it's accurate for you guys. On the third input, that is IUA's instrument. It's the flow. No, it's the position feedback for the flow control valve. And we know all those wires, so it's in. And the position feedback comes off the clay valve, 4 to 20 signal. Okay, on the next drawings is the F section, which is the communication, the radio from here to RP1. And there's a little diagram giving you the radio's IP address, its gateway, and its subnet. And then on the left is the actual PLC CPU. And under that, I've given you the PLC's IP and the HMI or the OIT's IP, which is the same subnet and gateway as the radio. So I only put the IP address of both. And it gives you a drawing of the components and from here to RP1 for the radio signal. Then after that, we go to section J, which is the panel drawings. On page 59, it's the complete layout of the drawings. And there's numbers, bubble numbers, which refers to the bill of materials. So if you see a bubble number 17, you go to bill of materials, line 17, it will give you what that part is, manufacturer and part number. I did not include in this set, there's another drawing, which would be drawing 60. All it is a terminal block rotation. It'll be only a view of the terminal blocks with their numbers and they're located. It'll just be a drawing of that group.
Blown up drawing.
Then we go to section L, which is starts at drawing 61. It's a loop drawing of the instruments at the site. The way this is set up is on the right-hand side is the actual RTU here. And then you have a dividing line, and anything that goes from this RTU into Weymouth's cabinets, which are over there, they're going to land it somewhere, and when we get it, we'll give you the real numbers. And then from their cabinet, it goes to field. So the left column is field, center column is MWD's cabinet, right column is IUA's cabinet. And that's how all this entire project, these drawings are laid out like this. If there's no MWD involved, it would be left side is field, right side is RTU, IUA, RTU. Okay, that's basically the layout for this section here, and it's the same with all of them. I included all the drawing, or a sample of all the drawings. And Savaine, I believe I printed them all because it's complete and we had all the information. Difference with the Savaine is drawing 18 of the package. There is no 120, it's all solar. So your first page in your section D is only going to be 24 volt because it's a solar system. And it gives you the power coming from solar panel, the circuit breaker, the device. And then after that we go to section E, which is the same setup as at this site. It's the PLC wiring. Once again, this is the first column, is the left side is field devices, card is on the right, so that's an input card. And on the second column, this is an analog card. The card is on the right, field devices are on the left, so that makes it another input card. It's not too much there, it's only 4 level transmitters, and then a couple singles for intrusion, and that's about it there. So it's a very simple cabinet. And also I have a, for Savaine, you have a wireless transmission for one of the level transmitters because it's pretty far away. So there you have a separate cabinet. The only thing in there is a level transmitter and a wireless radio, a Phoenix wireless radio. So in its communication, for its wireless communication, section F again, I have included that. We have the right hand side is the RTU with the antenna to RP1. Once again, I have the NET's radio, or the iNet radio's IP, subnet, and the gateway. And then right under the PLC's RTU, I have the OIT's IP and the PLC's IP. The gateway and the subnet are the same as the radio. So all that information's there. But in addition to all that information, I have the wireless from the level transmitter. So in here you have the Phoenix card, and then you'll have just the wiring, excuse me, the wiring, which includes the polyphaser for the lightning protection, the ground, and then to the antenna. One thing about the Phoenix radios is they're a match set. You replace one end, you have to replace both ends. So if you lose the transmitter, you have to replace transmitter and receiver on Phoenix radios. You can't replace just one. And this one's only using the analog, one analog signal and one digital signal, I believe is what it was. It's for the level and one for the intrusion into that panel down there. Okay, next section will be the J section. And this is the overall panel layout, front view, side view for make sure everything fit. Next drawing will be the inside of the panel layout at Savaine. So when you first open the door, you see the OIT on the swing out. That's what first thing you open the swing out. The next thing you'll see will be the terminal blocks and the PLC and the radio. And this is solar, so there's no UPS in this one. It has its batteries. We did the 48-hour test to make sure it ran without being connected to solar panels. We actually went like 68 or 70 hours, and it was still doing fine. So that's been completed. So here's the layout of the Savaine's panel. You'll have your, once again, top part, your power distribution. Then you'll have digital termination here and your analog termination there. The panel is very small. The Savaine's main RTU panel, the solar panel is a separate panel. The batteries, the solar charger, everything solar is in its own panel. At the RTU with the level transmitters, which is LT 2005, the solar and the radio are in the same cabinet. Okay, so that's one big difference. Then we go to our loop drawings, same as before. We have on the left side is field devices, right is to the RTU, and we give a description of the level transmitter. This one happens to be 2001. Goes through a direct terminal enclosure, which includes the surge suppressor, or the diodes, and then from there it goes into the terminal blocks in the cabinet. And I give you the terminal block, the fuse size is in there, and then it gives you the input of the card, the rack slot and point in that card. Then from there, we have, this is the wireless LT2005's panel. Like I said, it was only a level transmitter radio, so it's a very simple power distribution. Here's the power, there's the radio, and you're going to have power out to the level transmitter, which comes back in the radio, and that'll show up on the next drawing, or the loop drawing. You open the panel of the RTU 2005, there's no OIT in there, so as soon as you open the door, all you see is the batteries and the solar portion of the panel, and then here's the radio. It's very, very simple panel. Now for the loop drawings, we have the same thing. This is a loop drawing of LT 2005. So the level transmitter comes into the wireless IO panel 2005, shown here. Gives you the wiring, wire numbers, but then it goes to radio. So I've included the radio in the loop drawing, so you know there's a radio there. Yagi sends it to Ami at RTU 2000, and then from there it comes to the radio, and I show the inputs it comes to. These are the analog, or the digital. This is the analog inputs, all in the loop drawing. Then we have the next panel we'll be visiting as CB14. Very similar to this one. I won't even go over it. It's same layout. The big difference from 14 to 20 is 14 has 2 valves. 20 has 1. That's the main difference.
2 flow meters.
And 2 flow meters. That's 2 ergonomic left and have 2 pressures.
1 pressure.
1 pressure. So other than that, it's laid out the same way throughout the whole drawing package. Any questions on or concerns? Okay.
This is part of our groundwater recharging system, and it has the same communications as the others. It will communicate back. This one communicates actually back through RP4 to RP1 for the SCADA communications. There is a second panel on basin number 5, which controls sending out the analog signal and the intrusion alarm from that panel back here. That's the top antenna there. Bottom antenna is our communications to the SCADA. This particular site is set up from solar cell. We checked the UPS on this, and it ran from Friday to Monday without any trouble at all. So with the solar panel disconnected, in communications back to the SCADA, you can program here at this site. Can also be programmed from the SCADA. Once changes are made, they are recorded at both locations, so that if somebody makes a change at the SCADA while you're here, you'll see it, and vice versa. You make changes, they'll see it on the SCADA. Same login system is set up here as the others, IEUA_admin, same password. Now when we get in on this one, the main screen is strictly the 4 basins. We have basin 4 is not set up at this time for an analog signal for level. We have basins 1, 2, 3, and 5.
On one of those diagrams, you show basin 4s.
That's on the alarms, right? I just went ahead and set that in as a base basin. It's kind of a crowded screen. Should you guys go ahead and add in basin 4? There, all the other screens are easy to set up. I wasn't sure on that one. I just went ahead and left it. But the basin 4 does not report. And I left it out of the other screens so that nobody tries to actually program it or operate it. From all screens, just like the others, you have access to the alarm screens. It will indicate on that screen whether or not you have an alarm, and you can get there from any screen. The basin values gives you a numeric value on the bottom. The bar graph gives you a little bit of an indication of its range. So if it's close to being at maximum range, you'll be able to tell by the bar graph. If it's just barely full, you'll see that the bar graph's barely lit up. Now there is an offset capability on these because you can accumulate some water in each basin before the sensor can detect it. Once the sensor detects that water, it will report that offset plus whatever it is finding. So if the sensor is finding, say, 1 foot of water, but it's 7 feet from the bottom of the basin, it's going to report 8. As soon as that water drops below that sensor, though, it'll go to 0. It knows nothing about the other 7 feet of water that's part of the offset. If that makes sense.
And those offsets are set by what method?
They are, well, they're actually, if we go ahead and go to the next page on page 7. Actually, 7, I don't want to go over that in too much detail. Actually, this is a test screen. This is for supervisors. So if we want to come in and put in some values and see how they respond, see how the map is working on the different weather areas and volume, this is for the supervisor to go ahead and do. This won't be accessible from normal screens.
Yeah, so Andy, after this, we can go over it with you.
Okay.
And Barry would go over with you if you like. If you want to know how to do it. Andy.
No, Barry too.
I'll be dead before
Barry's got to know everything.
You're supposed to be optimistic, not
Yeah.
All right, let's go ahead and jump to page 10 then to answer that question. On page 10 is where we set our set points. That's our set point screen 1. There's nothing to operate on this particular panel like there is for a turnout, so there's no valves to turn on, no control over the water. All we're doing is reporting status. So on this screen right here, we have the ability to set all our low lows, low high, and high set points for our different basins. You'll see 1, 2, 3, and 5 on the bottom there. You also see the level offset, and that's where that can be set. It can be set local and or from the SCADA, so that's completely programmable. There's no apply button here either because nothing's going to act on it. If you put in the wrong value, you'll just be able to change it. It's not a big deal at this point.
Out of range warnings in case you want something to
like a high level alarm.
It's you can put in whatever you want.
The offset has to take this down.
calculation purposes of the amount of water that's in here, so we're going to run out of range. You can put the wrong number in for calculation.
It'll put in what you put in. It'll take what you put in. Right? It'll take in what you put in. We weren't given anything for range on that. Matter of fact, we have the table kind of laid. It's actually a little bit off. It has to be updated again. Anything like that.
Did you get a table for basic 5?
I know we get a table, but it was questioned as whether it was accurate by naming. So he knows where all those values goes in. It shows him where the data goes, and that's going to be just typed in. Those are not accessible from these screens. You do have to go into the PLC and make those changes for the tables. And he's planning on updating those.
Yeah, 5's not accurate because I think the file is 11.
We noticed that the debris in there. There is a second set point screen just like the other one. It's basically timers for heartbeats and for your analogs and etc. Not a whole lot of reason to get in there and make a lot of changes after that. We have the large screen. It's about the only other screen left on this particular panel. And again, I went ahead and put in 4 just for spacer. There are no controls, no monitoring on 4 at this time. When you guys are ready to put on 4, we'd be more than happy to get everything all dialed in and set up and a lot of that groundwork's in place to make it easier since we already had that on the others. On this screen, basically, we have the level alarms. We talked about the lows and the highs. We have an intrusion alarms, our wireless fault, and our communication fault. The wireless has to do with communicating to basin 5, and the communications back to SCADA. And those are about the only things that really can pop up on this particular thing. We don't have any power monitoring on this because when the power goes out, nothing left. So, any questions on this one?